So let's take a look at solving differential equations. For all of these problems, we have to find the exact solution to the differential equation given the initial value. So for problem number 1, the differential equation is dy dx equals 1 plus x squared over 2 with the initial value of 0, 1. So starting off with the equation, we don't have to worry about the coordinates just yet. We first have to be able to solve the differential equation. So in order to solve this differential equation, the very first thing we have to do is separate out the variables. So we have to keep y's on one side of the equation and x's on the other side. So notice that I only have one y, so I can keep that on the left side. So I get dy. And if I'm dividing by x on the left side, then I multiply to get rid of it, and I'll put dx over to the right side. So dy is going to equal 1 plus x squared over 2 times dx. So now what I can do is antiderive, or take the integral of both sides of the equation. So let's start out with the integral of dy. The integral of dy is just going to be y equals the integral of 1 plus x squared over 2 dx. So since there is a plus sign here and here, I can actually separate it out into 3 different integrals. So I can say y equals the integral of 1 dx plus the integral of x dx plus the integral of x squared over 2 dx. Now the integral of 1 dx is just x, and the integral of x, we can use the power rule, is just x squared over 2. And for the integral of x squared over 2, I can just rewrite that if I bring the 1/2 outside the integral. 1/2 times the integral of x squared dx. And so now, using the power rule, I get 1/2 times x cubed over 3, which is equal to x cubed over 3 times 2, which is 6. So now I can use the 3 functions that I've found and combine them. So y equals x plus the integral of x, which is x squared over 2, plus the integral of x squared over 2, which is going to be x cubed over 6. And since I've anti-derived, I need to add a plus c. And notice that I only have to do it to one side, and usually I'll just do it to the side that has x on it. So now that I have found my solution, notice in the beginning it asks us to find the exact solution. So we found the general solution because we have the plus c, but we need to find the exact solution. And to find the exact solution, it has given us a point of 0, 1. So we can just plug that into our solution and find the exact value of c. So I plug in 0 for x, and then 1 for y. So I'll get 1 equals 0, plus 0 squared over 2, which is 0, plus 0 cubed over 6, which is, again, 0, plus c, and c is going to end up equaling 1. So now I can write the exact solution. Y equals x plus x squared over 2 plus x cubed over 6 plus 1. So for number 2, we're getting dy dx equals 1 over x plus 4, and we're given the initial value of y of negative 3 equals 2. And this might seem a little confusing at first, but you can actually just rewrite this as negative 3, 2, because you plugged in negative 3 for x, and you get 2 as the y value. So now once again, in order to solve this differential equation, we just have to separate our variables out. Since there's only one y, we can put that on the left side, or keep that on the left side, so dy equals. Now in order to move dx over to the other side, I just need to multiply. So I'll get 1 over x plus 4 times dx. So now that we have separated our variables, we can integrate both sides. So integrating dy is pretty easy because the answer is just y. And to integrate 1 over x plus 4, we have to use u substitution. So if u equals x plus 4, then du is equal to just 1 dx or dx. So then I'll get, if I substitute that back into the integral, I'll get the integral of 1 over u du. And the integral of 1 over u is the natural log of the absolute value of u. And u is equal to x plus 4. So I can plug that in for u. So now I can put that back in the equation. So I'll get y equals the integral of 1 over x plus 4 dx, which is the natural log of x plus 4. I need to add the plus c. And now we can plug in our coordinates of negative 3, 2 into the equation. So I'll plug in 2 for y. So 2 equals the natural log, and then negative 3 for x, plus 4, plus c. So then I'll get 2 equals the natural log. Negative 3 plus 4 is 1, and the absolute value of 1 is 1. So then the natural log of 1 is 0. I should have put a plus there. The natural log of 1 is 0 plus c. So then c is going to be equal to 2. So now I can put this into my c and write out the exact solution of y equals the natural log of x plus 4 plus 2.